In this lesson, we will delve into the key issues in the design of angle iron lathe fixtures in Project 3. 1. The importance of balance in lathe fixtures. In lathe machining, angle iron lathe fixtures are a commonly used type of fixture. They can achieve specific clamping functions to meet the machining needs of different workpieces. However, when the lathe rotates at high speed, an unbalanced fixture will generate centrifugal force. This centrifugal force can adversely affect the lathe, spindle, cutting tool, and workpiece. From the perspective of machining accuracy, the centrifugal force caused by imbalance can lead to vibrations in the workpiece during machining, resulting in increased surface roughness and making it difficult to ensure dimensional accuracy. For example, when machining precision parts, even minor vibrations can cause the dimensional deviation of the parts to exceed the tolerance range, resulting in defective products. From a safety perspective, an unbalanced fixture rotating at high speed can cause severe vibrations in the lathe, which in extreme cases may lead to the fixture becoming loose or the workpiece being ejected, posing a threat to the operator's safety. Therefore, ensuring the balance of lathe fixtures is a crucial aspect that cannot be overlooked in lathe machining. Factors affecting the balance of lathe fixtures. 1. Uneven mass distribution. Angle iron lathe fixtures typically have a complex structure and are composed of multiple components. If the mass distribution of these components is uneven, it can cause the fixture's center of gravity to deviate from the rotational center. For instance, if a counterweight on the fixture is too heavy or a component is improperly positioned, it can shift the center of gravity. This results in unbalanced centrifugal force when the fixture rotates too. Manufacturing errors. During the manufacturing process of the fixture, factors such as machining techniques and measurement accuracy can lead to certain manufacturing errors. For example, errors in the flatness and perpendicularity of the fixture's mounting surfaces, as well as positional accuracy errors of holes, can prevent the fixture from maintaining an ideal balance during installation and use. 3. Wear and deformation. With prolonged use, the components of the fixture may experience wear and deformation. For example, the locating surfaces of the fixture, due to frequent contact with workpieces, may gradually wear down, leading to a decrease in positioning accuracy. Some structural parts of the fixture may deform under stress, altering the mass distribution and center of gravity, thereby affecting the fixture's balance. Principles of lathe fixture balance. The fundamental principle of balancing a lathe fixture is to align the fixture's center of gravity with the rotational center. According to the principles of mechanics, when an object rotates around an axis, if its center of gravity is on the rotational axis, no centrifugal force will be generated during rotation. Let the mass of the fixture be m, the distance from the center of gravity to the rotational center be r, and the angular velocity of rotation be omega. The formula for calculating the centrifugal force F is F equals mr omega squared. From this formula, it is evident that when r equals 0, meaning the center of gravity coincides with the rotational center, the centrifugal force F equals 0 and the fixture is in a balanced state. Methods for balancing lathe fixtures. 1. Static balancing. Static balancing is a relatively simple method used primarily for preliminary balancing. The specific procedure involves placing the fixture on a static balancing stand and allowing it to rotate freely. Due to the offset center of gravity, the fixture will stop at a certain position under the influence of gravity. By adding counterweights in the opposite direction of the center of gravity, or removing some mass at the center of gravity, the fixture can be made to remain stationary in any position, indicating that static balance has been achieved. Static balancing is suitable for situations with lower rotational speeds and less stringent balance precision requirements. 2. Dynamic balancing. Dynamic balancing involves balance adjustments while the fixture is in a rotating state. It requires the use of specialized dynamic balancing equipment to measure the vibration signals generated by the fixture during rotation, analyzing the magnitude and the location of the imbalance. Based on the measurement results, counterweights are added or removed at the appropriate positions to achieve balance. Dynamic balancing can more precisely eliminate fixture imbalances and is suitable for high-speed rotating lathe fixtures. In the aerospace field, the balance requirements for angle iron lathe fixtures are extremely high, necessitating precise balancing through dynamic methods to ensure that the machined parts meet the high precision requirements of aerospace equipment. 5. Aerospace lathe fixture balance standards and their ideological significance. In the aerospace field, the balance standards for lathe fixtures are derived from the zero-defect launch requirements. The machining precision of aerospace equipment parts is extremely high, and even the slightest error can lead to mission failure. Therefore, the balance standards for aerospace lathe fixtures are very stringent to ensure that dynamic balance is achieved at an optimal level. Here, dynamic balance is the safety baseline. Only by ensuring the balance of the fixture can the quality of the machined parts be reliable, thereby ensuring the safe operation of aerospace equipment. This reflects the aerospace industry's ultimate pursuit of quality and high emphasis on safety. It also reminds us in our daily mechanical processing studies and work to adopt a rigorous work attitude, prioritizing quality and safety above all. 6. Key points in the balance design of angle iron lathe fixtures. When designing angle iron lathe fixtures, it is essential to fully consider balance issues. Firstly, in structural design, efforts should be made to ensure an even mass distribution. Symmetrical structural design can be employed to make the various parts of the fixture relatively symmetrical in terms of mass and shape, reducing the likelihood of center of gravity deviation. Secondly, when selecting components, it is crucial to strictly control their mass and dimensional accuracy to prevent imbalance caused by component errors. Additionally, during the assembly of the fixture, it is important to ensure that all parts are installed correctly and securely, maintaining assembly precision. 7. Balance testing and verification. After completing the balance adjustments of the fixture, it is necessary to conduct balance testing and verification. Dynamic balancing measurements can be performed again to check whether the fixture's balance precision meets the requirements. Additionally, practical machining tests can be conducted to observe the vibration of the workpiece and the machining quality during the process, further verifying the balance effectiveness of the fixture. If the balance effect is found to be unsatisfactory, timely adjustments and improvements should be made. In this lesson, we conducted an in-depth study of the balance issues in the design of angle iron lathe fixtures in Project 3. We first understood the importance of lathe fixture balance, which has a critical impact on machining accuracy and safety. We then analyzed the factors affecting fixture balance, including uneven mass distribution, manufacturing errors, and wear and deformation. Next, we learned the principles of lathe fixture balance, which involve aligning the center of gravity with the rotational center. In terms of balancing methods, we introduced static balancing and dynamic balancing, with dynamic balancing being more suitable for high-precision requirements. We also discussed the balance standards for aerospace lathe fixtures, appreciating the ideological significance of dynamic balance as a safety baseline. Finally, we explained the key points in the balance design of angle iron lathe fixtures and the methods for balance testing and verification. I hope that through this lesson, everyone can grasp the relevant knowledge and skills regarding the balance of lathe fixtures, enabling you to correctly design and adjust the balance of lathe fixtures in your future studies and work.